Welcome to Mind Matters. Today, we're delving into a cornerstone of physics, Isaac Newton's laws of motion. These laws aren't just science class memories, they're the unseen forces shaping our universe. Over 3 centuries ago, Newton revolutionized our understanding of motion and force. His insights laid the groundwork for much of modern science. In this video, we explore these fundamental laws that govern how and why things move. From the inertia that keeps an object in motion or at rest to the relationship between force, mass, and acceleration, and finally, the principle that every action has an equal and opposite reaction. These laws are more than theories, they're everyday realities, from cars braking to planets orbiting. Join us as we uncover the practical applications and implications of these laws in our daily lives and the wider universe. Whether you're a science enthusiast or just curious about the world, this journey through the mechanics of motion is for everyone. Let's unravel the secrets of motion together on Mind Matters. In this segment of Mind Matters, we delve into Newton's first law of motion, commonly known as the law of inertia. This fundamental principle lays the foundation for understanding motion and force in the universe. Newton's first law states that an object will remain at rest, or in uniform motion in a straight line unless acted upon by an external force. It's a concept that's all around us, influencing everything from daily activities to the motion of celestial bodies. So, what is inertia? Inertia is the resistance of any physical object to a change in its state of motion or rest. It's a property inherent in every object, dictating how much it resists changes in its motion. A larger mass means greater inertia, making it harder to change the object's motion. Think of it this way, pushing a bicycle is easier than pushing a car, primarily due to their difference in mass and thus inertia. In everyday life, you can see inertia in action when you abruptly stop your car, and you feel pushed forward. This phenomenon occurs because, while the car stops, your body, due to inertia, wants to keep moving forward. Similarly, when a bus suddenly starts moving, you might stumble backward because your body wants to remain in its state of rest. Inertia also plays a vital role in sports. In baseball, a bat must exert a force to change the motion of the ball. The heavier the ball, the more force is required, illustrating how inertia affects the ball's motion. Even in the vast reaches of space, inertia is a key player. Planets orbiting the Sun maintain their paths due to inertia. They move in a straight line, but the gravitational pull of the Sun constantly pulls them towards it, creating an orbit. Without inertia, planets would either crash into the Sun or fly off into space. Understanding inertia also helps in engineering and technology. Vehicle safety features like seatbelts and airbags are designed considering inertia. Seatbelts hold you in place, countering the inertia that would otherwise cause you to move forward in a crash. But inertia isn't just a physical principle, it's a metaphor for resistance to change, in life and in the universe. Just as objects resist changes to their motion, we often encounter inertia in our habits and thoughts. As we conclude this section, remember that Newton's first law of motion is more than a scientific principle, it's a fundamental truth about the natural world. It reminds us that change, whether in motion or life, requires force, and understanding this law helps us perceive and interact with the world in a more profound way. Stay tuned as Mind Matters continues to explore the fascinating realms of physics and beyond. Welcome back to Mind Matters as we continue our exploration of Newton's laws of motion. Now, we turn to Newton's second law, which focuses on force and acceleration. This law states that the force acting on an object is equal to the mass of that object multiplied by its acceleration, commonly expressed as F equals ma. This relationship is a key concept in physics, illustrating how the movement of objects is influenced by the forces applied to them. To visualize this, imagine pushing a shopping cart. The harder you push, the force, the faster the cart accelerates. This is straightforward when the mass remains constant. However, if you were to load the cart with heavy items, you'd need to apply more force to achieve the same acceleration. This demonstrates the inverse relationship between mass and acceleration. In the real world, this law is observable in countless scenarios. When driving, your car accelerates more quickly when you press the gas pedal harder. In sports, a stronger kick to a football results in a faster-moving ball. The second law provides the mathematical framework to calculate the exact force needed to achieve a desired acceleration, making it crucial in engineering and design. Furthermore, this law explains why safety measures like airbags are essential. In a collision, the rapid deceleration of a car results in a large force, so airbags help to reduce the impact on passengers by increasing the time over which the deceleration occurs, thereby reducing the force. Newton's second law interconnects force, mass, and acceleration, allowing us to predict the outcome of applying a force to an object. It's a principle that not only governs the motion of everyday objects but also guides space missions, where precise calculations of force and acceleration are vital for navigating the cosmos. In summary, Newton's second law offers a powerful lens through which to understand how objects move and interact. It's a testament to the beauty and precision of physics, revealing the simplicity underlying complex motions. As we delve deeper into the laws of motion with MindMatters, the elegance and universality of Newton's principles continue to captivate and enlighten us. As we continue our journey with MindMatters, we delve into Newton's third law of motion, famously summarized as, for every action, there is an equal and opposite reaction. This law is all about interactions and how forces act in pairs. It tells us that whenever an object exerts a force on a second object, the second object exerts an equal and opposite force on the first. Consider the simple act of walking. When you walk, your foot pushes against the ground. According to Newton's third law, the ground pushes back against your foot with equal force in the opposite direction, propelling you forward. This interaction is why we can move on the ground instead of sliding endlessly. This law is also beautifully demonstrated in space travel. A rocket launches into space by expelling gas out of its engines. The rocket exerts a force downward on the gas, and, in response, the gas exerts an equal and opposite force upward on the rocket, propelling it upwards. Another common example is the recoil felt when firing a gun. The bullet is pushed forward, and simultaneously, the gun is pushed back with equal force, which is felt as a kickback. On a larger scale, this law governs the interactions of celestial bodies. Planets orbit stars due to the gravitational force between them. The star pulls the planet toward it while the planet pulls the star with an equal force in the opposite direction. Newton's third law is fundamental in understanding how forces work in pairs. It's not just a principle confined to physics labs but a part of our daily life, dictating how objects and forces interact with each other. This law helps us understand the dynamics of motion and balance in the universe. In essence, Newton's third law teaches us about the symmetry in the universe. Every force and motion has a counterpart, and understanding this is crucial to grasping the basics of physics. As we progress through MindMatters, we realize how these laws are not just rules but the poetry of motion, describing the harmony and balance in the natural world. In this installment of MindMatters, we explore the profound impact of Newton's laws of motion on modern science. These laws, more than mere theories, are the bedrock upon which much of contemporary physics, engineering, and technology are built. Newton's laws have enabled us to understand and predict the behavior of objects under various forces, a foundational concept in physics. This understanding is crucial in fields like aerospace engineering, where accurate calculations of force and motion are essential for designing safe and efficient aircraft and spacecraft. In automotive engineering, these principles help design vehicles that optimize performance and safety, particularly in terms of handling dynamics and crash safety systems. In sports science, these laws assist in analyzing athletes' performance. Understanding the mechanics of motion helps in optimizing techniques, enhancing performance, and reducing injury risks. In the realm of architecture and construction, the principles of force and motion are applied to ensure stability and resilience of structures under various stress factors. Beyond these practical applications, Newton's laws have also paved the way for further scientific discoveries. They were the stepping stones that led to more complex theories in physics, including Einstein's theory of relativity and quantum mechanics. While Newton's laws apply to the macroscopic world, they set the stage for exploring the microscopic and cosmic scales of the universe. These laws also play a significant role in our understanding of renewable energy sources. For instance, in wind turbines, understanding the dynamics of motion allows for the design of more efficient blades to harness wind energy. Newton's laws of motion have not just shaped scientific understanding but also influenced how we interact with and manipulate our environment. They have become a fundamental part of the curriculum for students worldwide, shaping the minds of future scientists and engineers. In summary, the legacy of Newton's laws of motion extends far beyond their historical inception. They are living principles, continually applied and explored in modern science and technology. As we continue to advance, these laws remain a testament to the enduring power of scientific discovery and innovation. Stay tuned with Mind Matters as we further unravel the mysteries of the universe and the laws that govern it. In our next Mind Matters episode, we explore the ubiquitous influence of Newton's laws of motion in our everyday lives, often in ways we don't even notice. These laws are not confined to the realms of academia, they are the unseen forces that shape our daily experiences. When you throw a ball, drive to work, or even just walk across the room, you are living within the rules set by these fundamental laws of physics. Consider your morning routine. The act of getting out of bed and walking to the kitchen is a practical demonstration of Newton's first law of motion, inertia, and the third law of action-reaction. Your feet pushing against the floor and the floor pushing back propels you forward. When making your coffee, the second law comes into play. The amount of force you use to press the coffee plunger is directly related to the mass of the plunger and the acceleration you can impart. Even in leisure, these laws are at work. In sports, for example, the force applied to a ball and its subsequent motion follow Newton's laws. The same principles govern the flight of a bird or the flow of water in a river, illustrating the seamless integration of these laws into the natural world. Our understanding of these principles has also led to advancements in safety and technology. Car safety features like airbags are designed considering the laws of motion, particularly to counteract the effects of inertia in accidents. Newton's laws of motion, thus, are not abstract concepts but tangible, everyday realities. They remind us of the elegance and order in the physical world and our continual interaction with these fundamental forces. As we navigate through our day, these laws guide everything from the simplest to the most complex of our actions, making them a constant yet often unnoticed backdrop to our lives. As we wrap up our journey through Newton's laws of motion at Mind Matters, we've seen how these fundamental principles shape our world. From daily activities to cosmic phenomena, these laws are ever present. We hope this series has sparked your curiosity and deepened your understanding of the universe. Don't forget to like, share, and subscribe for more insightful content. Join the conversation in the comments below and let us know what topics you'd like us to explore next. Keep questioning, keep learning.